In this video, a timeline process simulation overview will be presented. This simulation feature allows you to analyze processes of interest and test your assumptions regarding this process. The whole idea of using the simulation is based on two things. You have a given process to analyze, and you have a hypothesis to test for this process. Once we have our hypothesis prepared, our remaining work is split into two steps. Step 1, preparing the process. Simulation analysis is based on a pre-configured schema with optionally applied filters. Step 2, actually testing our hypothesis. So we have an invoice process which we want to improve at some points. Let's take a look at the part of the process where one event is looping. We see that the process can go from ERP export to quality control and then back. And if we check the duration of such transitions, it appears that we spend pretty much time on it. Let's concentrate on this node. If we go deeper, we can see that the quality control event is also money consuming. Our aim is to decrease both the processing time and the cost of our invoice process. So we have the hypothesis that minimizing the quality control event occurrences will influence the whole process correspondingly, decreasing both the time and the cost of the process. So bearing this all in mind, we want to start our simulation analysis. The first step is preparing the specific process we want to analyze. Again, simulation analysis is based on a pre-configured schema as well as optionally applied filters. We will work with the whole set of data. We created the schema, gave it a unique name, and now we are opening the simulation module. We are giving a name to our scenario and selecting the milestone schema, as well as configuring general settings, start date and stop condition. We want timeline to take into account the whole set of data, and we're defining a specific number of timelines as a stop condition. Note that 1,000 timelines is a number given just as an example. You can specify any number you want, taking into account that a scenario created based on 1,000 timelines out of 13,000 and another scenario on 13,000 timelines out of 13,000 can of course give you completely different results. You can also analyze the resources derived from your project or added manually. We add the clerk resource and specify the same number as we have in the project, given that we are not going to change our number of staff. Now we are mining the behavior according to the settings we made. We set up the quality control node according to our assumption. We want it to go straight to the next event without coming back to the previous event. In our case, we will change the distribution of percentages between two events, more to the reroute event, less to the ERP export event. So we are changing the fork distribution of the outgoing transition. Also, we know that for quality control, we need our clerks involved, so we specify resources in the incoming transitions. That is, we specify the resources for the specific event. As you see, you can also change the duration of transitions. Let's also try this and decrease the time by 25% for transitions back to the previous event. We are running the simulation now to see the results. The results are depicted in the Results tab. The Process tab shows general process information, how many timelines were generated, their duration, and cost. Let's take a look at this tab. Note that we can compare our results with the mined set, another simulation scenario, or the current set. We will compare with the current set, that is all the project data. Our assumption was that our new setting in the quality control event will decrease the duration and cost of our project. And surprise, things appeared that we didn't expect. Yes, we reduced the cost, but the duration increased by 1.5 times. Let's go to the Milestones tab to see more details. The Milestones tab shows results broken down by schema milestones. We can see here that changing the quality control event conditions greatly influences its following events, either decreasing or increasing the transition duration. But in the end, it is what it is. The common duration increased. Note that our waiting time increased in our quality control event. The waiting time is calculated from our resources information. A more detailed view is given in the Transitions tab. This tab shows generated transitions, their amount, duration, and cost. The duration of the transitions depends on the configuration of the time distribution histograms, where we change the time spent on transition and the waiting time calculated from resources. And here we can have a more detailed view on all transitions and analyze specifically which transitions can take more time than in our current set. And last of all, our Resources tab. This tab is optional and is depicted only if you define the resources for one or more nodes. The Resources tab shows waiting time and processing time for resources if resource demand is configured. So this is our simulation. As you see, there are plenty of surprises that can appear if you test your assumptions via this tool. That said, amongst all its many advantages, process simulation is particularly useful when you want to change your process because it can keep you from making a lot of mistakes that you couldn't have predicted without this unique and powerful analysis tool.